going to use the 2-rail sweep under Surface. And I'm going to continue that for the rest of the shapes over here. So we'll do 3 more and then continue. Next we're going to use Offset Surface under the Surface menu. And when you use Offset Surface, first you select the surface and hit Enter. And you can click on the surface to choose whether you want it to offset up or down. In this case we want it to offset up, and pick our distance, enter 3, and then hit Enter when we're finished. Do one more and then we'll continue once the rest of the surface has been offsetted. So again we want to click up and then we'll continue at the end. Now that we've offsetted each of the surfaces 3 units, let's take a look and see what kind of problems we have that we have to fix using other commands. The first one is this corner here, and one way that we can help remake this corner and then also align these edges with the edge of the box is by using 2 commands. So we'll start with this corner here by extending this surface. So we'll go to Surface, Extend Surface, click on the edge, and we'll use an extension factor of 18 just as an example. And we'll do that for the opposite surface. Now that we have 2 surfaces intersecting each other, we can use another command to find the intersecting edge. Go to the Curve menu, and then Curves from Object, and select Intersection. Now we select the 2 objects that we want to create a curve from the intersection. Hit Enter. And you'll see a yellow line has been created at the precise corner of these 2 surfaces. Now let's work on the further edge. You can see now that I've extended those 2 edges outwards just to make sure that I have enough edge hanging over our limit so I can project this line down and find my cutting plane so that I have a precise box for this facade unit. But I need to do this in the top view by typing project. Now it's asking for the curve to project. I want to use my one of my blue curves from the box, which is the limit, and then hit Enter, and then select the surface I want to project onto. When I hit Enter, a line has been drawn here, which is where I will be using as the bounding line of that shape. Let's do that for the other edge, and then we'll delete these 2 surfaces and create a new 2-rail sweep to recreate the surface from new curves. Before we delete these surfaces that we're just using to create the edge curves of what we want our new surface to be, let's duplicate these edges to make sure that we have a 3rd and 4th edge for our 2-rail sweep. The way that we can do that is by going to Curve from Object and Duplicate Edge. Now let's select these edges here. Hit Enter. And make sure you're selecting the top curves that we've just offsetted, because the bottom surfaces are okay already. Now I'm going to delete these surfaces. And now we need to trim the lines so that we have exact lines to use in our 2-rail sweep. And then we're trimming these lines as well. It's okay to trim curves in this exercise, but let's try to avoid trimming surfaces because it creates strange geometry that's hard to edit and hard to merge edges when we're aiming to export this as an STL file at the end of the exercise. So now we have our 4 edges. And let's do a 2-rail sweep. So I'm selecting 4 edges, hitting enter, then OK. And now the outer edge. Surface, or your final STL output. But I'm going to turn it off just so we can look at the main geometry of the facade first. So I'll turn off the box. This geometry here could be used to extrude to create the box later. First we select all the geometry that we want to do a analysis on to find which edges we need to merge. So I'm going into Analyze, Edge Tools, and Show Edges. And a toolbox opens over here. I'll pull it off to the middle. What we want to see are the naked edges. And first we can, if you click zoom, it'll usually lock in on one of the edges to work on in editing. You can see it over here with my cursor. Every time I go next, it'll go to another one to work on. This is useful to navigate around your model looking for edges to merge, but I'm just going to use the manual viewport to do it. And the command that I need to use is Edge Tools, Join 2 naked edges. Asking for select 2 unjoined edges. I'll click the edge once and select one edge. It turns yellow, and then I select it a second time. It'll give me a warning about what tolerance is being used to join this edge together. Just say yes and not worry about it. And let's continue this command for all the other various edges. And it looks like there's about at least 40 to 50 edges that we'll be doing this for. You may find that you have more than one surface copied on top of each other, which is preventing you from joining your edges. And you may find that some of your edges weren't made very well and have holes that are hard to repair by dragging the points with O-snap-on. So in some cases you may need to just delete the face and then rebuild it using a surface tool and then try to join those edges together before exporting to STL. Sometimes the join command can help you speed up the process if some of your edges are already made clean. I'll do the join command and deselect, and it'll show me which edges I still have yet to join. So we found some surfaces that were copied on top of each other that needed to be deleted. We can only join one surface to another surface. So once we cleaned up the geometry, now we have all edges joined. And there's a few more checks that we can do in order to determine whether the geometry is done nicely. And one command is called direction, and this is checking all the surface normals to make sure there's no flipped faces. If I do the same command on this geometry here, you can see that there is some flipped geometry in there that needs to be reflipped. And the second command that I'll use is called select closed polysurface. And it's only selected these 2 out of the 3 geometries because this one is not closed. It still hasn't had its faces joined. That means that it's true that this is a closed polysurface and will export possibly into an STL file without error. The next step is that we can convert this into a mesh. And you can see the triangulation here that will be used to rationalize your geometry before it gets exported to an STL. And depending on the fineness